All right. Welcome to the introduction to even and odd functions. And here are the definitions that we're going to focus on when it comes to even and odd functions. Now it says a function f is an even function if f of negative x equals to f of x for all x in the domain of f. The graph of an even function is symmetric with respect to the y-axis. A function f is an odd function if f of negative x is equal to negative f of x for all x in the domain of f. The graph of an odd function is symmetric with respect to the origin. Then it says, by inspection, determine if the function is even, odd, or neither. Because these are graphs, we're going to determine if the graph is symmetric with respect to the y-axis or if the graph has symmetry respected to the origin. Now, for the first one, there is no symmetry with respect to the y-axis. Because if I draw a line through the y-axis, the right side does not mirror the left side. Symmetry means it must be an exact mirror. So in this case, there is no symmetry to y-axis. We don't focus on the x-axis in this case. We're done. Now what we want to do is we want to find to see if there's symmetry with respect to the origin. Now when it comes to the origin, you're going to draw a line, a diagonal line. Doesn't really matter the way. A diagonal line through the origin. Now we want to determine if the function on top will look at the function on the bottom. And if you want to, you can turn your screen or turn your paper 180 degrees. And if you turn it 180 degrees, it has to look the same. So if you turn your paper or your screen 180 degrees, this function will look exactly the same. That's called turn symmetry. And because that is the case, there is symmetry with respect to the origin. Which means this is an odd function. This is an odd function. Can't even write odd correctly. Now, we established that it's an odd function, right? I want to prove it to you. Let's take this point of 1, 1. Take the point of 1, 1. So in this case, x is 1, y is 1, right? But remember, we can always write y as f of x. So I'm going to say f of x equals to 1. Now, it says if a function is an odd function, f of negative x will equal to negative f of x, which means to determine if it's an odd function, I'm going to change the sign of the x value. So if x is 1 in this case, then that means negative x will be negative 1. And to prove if it's an odd function, that means if I have negative f of x, that means I must change the sign and make that negative 1 as well. Now, what we're going to do is we want to see if this coordinate, if negative 1, is on that graph. So if I go to my graph and try to find negative 1, it is right here. Negative 1 is right there. So therefore, yes, this is also an odd function by doing that as well. By changing, remember, if it's an odd function, if you change the sign of x, you must change the sign of y. And that same coordinate must also appear in that graph to be proven an odd function. And because that same coordinate appears, that is more proof that this is an odd function. I'll do it again when I do the next one. So, the second one, y equals f of x. Now, remember, if it's even, there is symmetry with respect to the y-axis. So I'm going to draw a line through my y-axis and see, does my left side look like my right side? And if you look here, yes, it does. The right side is a mirror image of the left side. So there is symmetry to the y-axis. Therefore, this function is even. That one's pretty straightforward. This function is even because if I draw a line through the y-axis, highlight it, or if I fold it about the y-axis, the left side will look like the right side. Now I'm going to use the same tactic that I did up here. Now remember, if it's an even function, if f of negative x equals to f of x. So let's take the coordinate right here. This coordinate, that's going to be the coordinate of 1, 3. So this is x, this is f of x. It says if the function is even, if I change the sign of x, the y will remain the same sign. So what I'm going to do is I'm going to change the sign of x. So if I have negative x, I will now have negative 1, but f of x will remain the same. I will not change the sign of that, which means my f of x should remain as 3. I don't want to put f of 3. I'm going to put f of x. The f of x will remain as 3. And now we want to see, can we find that coordinate on this graph? When x is negative 1, y is 3. And that appears right here. Yes, that is an actual coordinate on this graph. And because this is an actual coordinate on this graph, that means yes, this is an even function. Because when I change the value of x, the y remained the same. The y remained the same value with the same sign. If it's odd, it would be the same value with a different sign if I change the sign of x. And the last one, we can determine that this is neither. Neither, because the left side does not look at the right side. If I draw a dashed line, either here or here, the top half of the dotted line does not mirror the bottom half of the dotted line. So this is an option of neither. So neither an even function nor an odd function. All right, guys, that is it to this video. Hope you guys enjoyed it, and I'll see you soon. Take care.